Okay, do you hear me? Yes. Okay, so welcome everybody to this PuppetCamp, Puppet Day at the RMLL conference. Just a couple of words before I let Teyo start his presentation. First of all, we have T-shirts here on the first row, free for you to just grab one. There are 3 sizes. So after the talk, just please come in the front and take one. Other thing for the lunch at midday, I don't know if you are aware, at the front desk you can buy for I think 10 francs vouchers for a meal at the cafeteria, student cafeteria over there. Otherwise, there are plenty of restaurants outside. And the last thing, this evening there is the conference closing banquet that takes place sort of 10 minutes on foot in this direction. And if you want to take part, you must also buy a voucher for 30 francs, I think, at the front desk. So I'll let Teyo talk now. Thank you.
Hello. It's a big room. Thank you guys for all being here. One of the things I like to say at all these, or fall down, at all these puppet camps is that our European community, puppet community, is really important to us. You kind of have helped us grow, and it's humbling for us to come out here to these events and see so many people. Just a year ago, we had 2 major events a year. Those events, one was in the States and one was in Europe. And we had 100 people. The first one we had 3 years ago in San Francisco, we had 60 people. 600 would have been awesome. Scary, but awesome. But it's amazing. We're traveling around Europe. We're doing one of these, I think, almost once a month now. And we're having great turnout, great questions, great interactions. So I just want to thank all of you guys for that. And thanks for your interest in Puppet. As you see in the Puppet code up there, I'm one of the co-founders of Puppet Labs, and I'm head of business development, which might seem weird for a community event, but we'll get to that in a little bit, why it's important to us. So I know I was supposed to talk about PuppetDB and the Puppet roadmap, and I'm going to hint on those, but what I've discovered from doing these camps is that there are a lot of people that don't really even know what Puppet is. So I'm going to do a small introduction of Puppet, and then I'm going to cover some other things. And I might be a little bit all over the place. So we have kind of a non-linear description of what I'm going to talk about. So I want to talk about a little bit about what Puppet is, and what's new in Puppet, the things we're working on. And then I want to talk a little bit about myself because I'm arrogant, and it's things I know about. So I'm going to just talk a little bit about what business development means at Puppet, and then we'll give you guys an opportunity to have a bit of Q&A with me while I'm here about the things I've talked about or any questions that you have whatsoever. So we'll make sure we leave some time at the end for that. Can everyone hear me okay? All right. So what is Puppet? It's really simple. Puppet is a tool for managing things on things. It's that generic. We want to understand the state of something, and we want to make sure that we keep that in a consistent state. We can do this on the command line very easily with Puppet. And so on this slide, you can just see that we're calling something Puppet resource, and the resource is user, and the user's Teyo, and we're just ensuring that user's present. So on a system, that makes a lot of sense. So we call these things on things that we manage, we call them resources. It's a really generic concept, and it's not like your traditional concept of a resource on a computer, like the amount of disk or memory, but the things that you manage, the unit of things that you manage. And it's important that it's open and that generic, because it gives us a lot of power. That simplicity gives us a lot of power. We can define ourselves what we think a resource is. We can say that this little bit of a configuration file in our world is viewed as a resource, and we want to manage the state of that little bit. So kind of dig into this a little bit more. In Puppet language, that little bit is the resource type. So we can have multiples of these types of resources. They're really generic. In this case, we're saying package is a resource type, right? And then the package has a name. We're going to ensure it's OpenSSH. And the last bit is we're going to ensure that it's the latest version. And that's an attribute for the resources. It's a really simple mapping. And the great thing about this is the same mapping you would use if you were managing a Solaris system, an Ubuntu system, a Mac OS system, a Windows system. It's the same language. We try to make that really, really simple and really, really easy for people to understand. So today, the things we manage, the things on which we manage resources, are computers. But that's not the only thing that we want to do. We also have, and Brice over here added this to the Puppet ecosystem, the ability to manage switches in the same way, using the same language, this convergence of management. We also have support for load balancers today. We're adding support for things like virtual machine management and all kinds of interesting things. So you can use the same descriptive language, the same state management system that we built across things that aren't computers. So Puppet is also a language. We showed in the earlier slides was just simply using Puppet from the command line to manage stuff. But you can put together descriptions of things that persist. That you say, here's a description that I want to have for all my machines that I'm managing that will keep the state in sync. So you can describe to your computers the state you want them to be in, not how to get into that state, just how the state you want them to be in. It's a really simple concept. And just like we had in the command line, we have resource types. So it's really similar to the command line options. We have a file resource, the file source. So we're saying, serve this file up from some file server. And then we have the resource title or name. This is surprisingly revolutionary for people. It seems really simple. I think people that have been doing automated configuration management, this seems like a really simple thing. But I spend my time going around to people that haven't been on the forefront of trying to manage their systems in an automated way. So I might be at VMworld. We have a bunch of people that have 100 computers. They're managing all manually. There might be virtual machines, but they're managing them all manually. And as soon as I tell them that they can specify a simple configuration file that can be managed across all their machines and kept in sync, it blows their minds. They're like, how do I do this? Am I writing shell scripts? Why do I not have to tell it how to make that so? And so things that I think people that have been using Puppet or tools like Puppet for a long time take for granted are somewhat revolutionary for folks. Finally, Puppet is a framework for ensuring that the actual state of your machines matches their desired state. In the previous example, we were actually cryptographically ensuring that the file matched the file on our file server. If you run Puppet over and over again, the way it behaves is just ensures that state. It checks the state and ensures the state. We have a simple diagram of this in action. So without going too deep on the different components here, we have a concept of a node, the managed host, the thing you're managing in Puppet. And that node has to send up from its self information that the management node, the Puppet master, couldn't know about it. So things like what its IP addresses are, how many interfaces does it have, how much memory does it have. Those things are all pertinent to how you end up describing the configurations. You pass those facts into the Puppet master. The Puppet master takes those, and using the Puppet language, the descriptive language that we just kind of hinted at earlier, it also has conditional logic, so you can do some branching of your models. It creates what we call a catalog, which is a map of all the things you want configured and all their relationships. And it passes that down to the client. And it's literally data. It's not how you get there, but it's the end state. It's a map of the end state. And then the node consumes that map and then reports on any changes that it made or any failures that have happened. And then it passes that report back. So you not only get this map and this enforcement, but you also get the information about what's happened across all your machines. So that's, in a nutshell, what Puppet does. It's a very simple concept that we've extended to model the end state for all of your systems. All right, so for the people that already knew all that stuff and have been just waiting for me to get to interesting things, I want to talk a little bit about what's new in Puppet. We've been doing lots of interesting experiments, and we've been trying to resolve some of the issues that we've had with our approach. And one of the first things that I think is really interesting that we've come up as a solution is Hira. So one of our goals at Puppet Labs was not just to allow all of you to do what I just showed in those previous slides, but since we can describe the end state we want systems to be in at a higher level, we have this ability to share those end states, share those models with one another. Well, the problem is that everybody has some things that are very particular in their environments, or that might even need to be differentiated within their own environment. So you can't go into a Puppet a Puppet description of a system and share it with everyone when you're using your static NTP server or something. So say you're managing NTP. And so what we wanted to do was provide some simple way to look up this data that we want to parameterize. Things that we don't want to hard code in our models of the world because we want to share them. So Hira allows us a way to hierarchically look up some data within Puppet. Today, that's a separate functionality. So there's a function to look up this data from external sources. But in the next version of Puppet, that'll be just part of Puppet. So you'll be able to take advantage of this hierarchical store. And by hierarchical store, I mean it's pluggable. So you can say, like, inside of my Puppet module, there's some data that I want to use as defaults. But I might also look into my LDAP database, or I might look into Hira's built-in backends for some data. And I might match based on what my operating system is. It's just a way for you to parameterize that information and pull that out of the shared configurations. And I know this is listed as what I was supposed to talk about in depth. But PuppetDB today, there's a couple things that are important about it. But the first thing is just a drop-in replacement for a tool we called stored configs, which is one of maybe the most poorly named tools in the world. But stored configs allows us to take those models that are described in the graphic earlier and use those models to configure other hosts. So say, for example, you have the very simple example of a load balancer that needs to configure itself for some web servers that you're managing. If you have all the information about the web servers you've configured, then you can configure that load balancer. And we built some things into Puppet that allow you to do that lookup, to map that. PuppetDB just drops in a replacement that's actually performant. So our initial implementation of that was just not very fast. Now, the extension of PuppetDB beyond just that simple use case that I described is pretty vast. We plan to store a ton of interesting things in there. We're actually storing the entirety of the catalogs today, so not just things that we want to look up, but the entire maps. So you'll have literally an active configuration management database. So of all the machines and all the models that you have, you'll be able to look that up and maybe interestingly do like analytics on your environment from PuppetDB. It's fast. And it's also designed to be storage efficient. Imagine someone that has a lot of nodes that's trying to use PuppetDB to store all their node information. That storage needs to be efficient because the amount of data that it would create would be excessive. So if you have 50,000 nodes and they're checking in every 30 minutes, creating a model or applying the model, and that you're not deduplicating that information, that's quite a bit of duplicated data. So we do a lot of deduplication in there as well. Also used to store the information about the nodes that we call facts. So that's kind of the intrinsic information about a system. That's also stored in PuppetDB. And then the next thing to go in will be the reports that Puppet produces. So we'll also have the benefit for efficient and fast report storage. So the great thing about that is you have an inventory of all your machines, their models, and all the things that have ever happened to those machines over time. That is useful, and we plan to build lots of interesting tools on top of it. Razor, this is something that I actually am proud of and personally invested in. I've always wanted to have a better provisioning system for hardware. Everyone that uses Puppet has to solve that problem themselves. Like, how do I get a node up to a point where it's running Puppet and it can configure itself? And there are plenty of tools out there that you can do this with. The design decision for Razor really kind of came from this desire to have a bare metal provisioning tool that looked a lot like the way you provision instances to a virtual environment. So with Razor, what you can do is inventory all the capacity that you have physically, all the physical capacity you have, by simply booting up a small in-memory kernel that has factor on it, and it registers the information from all your hardware. So literally, you can stack up a rack of servers, pixie boot them with this microkernel, and you have an inventory. And then they're in a state of being ready for provisioning too. And then you also have the capacity to make some rule-based assignment of capacity to those things. So say I want all of my machines that have 32 gigs of RAM and are on this network to be configured as compute backends for my cloud. You can make those rules in Razor. And then there's also an interface for cleanly handing off the desired outcome from the machine to Puppet. So you just simply boot up a machine, it hands it off to Puppet and configures itself cleanly. The main the thing that I thought that was really important differentiating between bare metal provisioning and physical provisioning was that in the bare metal provisioning world, you're really talking about an inventory, and we just didn't find out there in the world there to be anything that did a sufficient job of automatically inventorying your systems for you. Since we had Factor, our friends at EMC thought, why haven't you guys done this? They wrote the software and then said, we can't do open source software, and they just gave it to us. So we benefited from that. The next version of Puppet is Telly. It's in RC today. And we've made some decisions internally at Puppet Labs to delay the actual release of Telly, and they're for good reasons. The reasons are we want to improve performance. So we've got all these new features in Telly, we've added Hyra, and now we're just going to push really, really hard on making it as fast as we possibly can, because this is what everyone wants. People want features. They want things like Hyra added to Puppet, but we want to make sure that it's performant for people. Not that you can't scale Puppet out to a large number of nodes today, because you can. We have people that use Puppet over hundreds of thousands of nodes, but that requires more resources than you should have to use in order to manage Puppet, and also the speed is not exactly where we want it to be. So we're intent on improving performance of Puppet in the next release, and so now that we have feature freeze, we're just going to focus on making it as fast as we possibly can. All right, things that I know about deeply and what I do at Puppet Labs. So I'm head of business development, and that sounds like I wear a suit and tie and glad hand a bunch of people, spend a bunch of time making promises to our customers that we're not going to keep and all those kinds of things. But that's not what I do. Puppet is still not a big, giant company. We are 80 some odd people now, but we're a small company. And so if I go and try to have negotiations with a large company like VMware or Red Hat or any of the companies that we might work with, they have tons of resources to throw at stuff, and they're concerned about why we don't want to work with them and do all the things they want us to do. And we have this happening all the time. So this is a wonderful problem to have, because we're still a small company, but because of you guys, because of people using Puppet, Puppet is huge. It's everywhere. I'm surprised every day by the places that I see Puppet being used. I think I was talking to people out in the hall. Puppet is being used by the SpaceX program, which is a commercial effort for space exploration in the States. So they're using it to manage their back-end systems. The guys from CERN, there's a ton of people from CERN here. They're using Puppet. They're moving to Puppet. And also like gov.uk. So we're everywhere. And it's humbling and exciting, but it also leads a ton of people to want to talk to us. And firstly, I want to thank you guys, because your willingness to use Puppet and try to like make your lives better by using software we write is literally humbling. But it's this adoption, this prevalence of Puppet that is driving people to talk to us. So because of this, we're completely swamped with integration requests. People want us to integrate with whatever their pane of glass is for their cloud thing. Everybody wants to have a Puppet story in the world, which is surprising to us and humbling at the same time. But we basically have more opportunities for integration than we can act on. And if there's anybody out there that wants to do integration with us and I owe you an email, I apologize. It's something that we're overwhelmed by. So because of this, again, thank you guys. Because of the opportunities that we have being things we want to act on, and not just that we want to act on because we think, wow, if we integrate with Red Hat's offering, it's going to make us a bigger company and tons of money. Those are things that we care about for the sake of the project being successful. It's important for us to make some money. But more importantly, it's this idea of ubiquity and consolidated management. So if we have the opportunity to write Puppet integrations with things that we can't manage today, or if we make it easier for you to take someone's open source project and deploy it because it's Puppetized, that's good for not just Puppet Labs, but for the community. So the way we've been approaching business development is with that in mind. So the concept that I've come up with is business development as a community process, largely out of necessity because we don't have enough resources to meet the demand, but also because we felt like it was the right thing to do. So when someone reaches out to me and says, I want Puppet to integrate with, F5 load balancers, and then we ask them if they want to participate in the community process around that. We make those things open source and freely available on our Forge, and we want to do that with as many integration possibilities as possible. So we have people that are ISVs that have their software that just want to be able to easily have their customers accept it, and people are demanding that. There are some customers that are literally telling their vendors that, well, if we'll use your software if it's Puppetized, which is great for us, but it shows the ubiquity that we have. We also have we also have hardware companies that want us to integrate with Razor now. So we've gone into a new area of management, and also hardware companies that are doing things like load balancers like NetScalers from Citrix. Those folks want us to be able to apply our same model, this idempotent model, which turns out to be really popular and really successful, to their load balancers. And it's interesting when we talk to these folks that are like network admins or whatever, when we go, look, you can describe the state you want to switch to be in and test to make sure it's in that state and version control it. And it kind of blows their minds. They're kind of like, we can do that? Because they're used to either logging into their GUI and configuring things or using a command line tool that immediately does it, but they can't model the way they do their jobs, the way that the systems are configured. So that's a really interesting area for us. And then finally, other open source projects. And this is something that Dan Bodie will talk about when he gives his talk. What we want to do is be in alignment with people's processes for both delivering quality software and also making it easy for their users to use that software. So what we try to do is get in alignment with their build pipeline. So if we use Puppet in open source software's QA environments, if they use it to actually build up their QA environments, then there are already models of how you would use Puppet to deploy the latest version of their software. So if we can get into that build pipeline, we can both ensure that the open source software is better quality and meets end user demands, because end users are demanding, here's how I use your software, and that's described in Puppet, and then you pass that through the QA process, and at the end you have well QA'd software and a model to deploy it, and that's the end goal for us. And we've had some luck with this kind of approach where we think of Puppet business development as a community process. And we're early on in this, but Razor is certainly an example of that, where we spoke with EMC. They'd already started working on it, and we insisted on them doing something that was unorthodox for them, which was open sourcing some software. And then OpenStack, which is a great story, and this is what Dan's going to talk about, is an example of us being part of a community and making sure that we are part of that QA process and building community around our OpenStack modules. And then finally, CloudStack, we just recently went to Citrix and trained their entire QA staff. We just said, look, you guys need to use Puppet. It's going to make your lives better. And if we go and write Puppet modules for CloudStack, they're going to be out of date the next time you release software. So how can we work together? How can we make your lives better and then also make our users and your customers happy? So the moral of this is, while I can do so many finite things in business development, you guys can do business development for us as well. If you have Puppet code for managing things that doesn't already exist on our Forge, or even it does, but you have a better way of doing it, publish that. Publish that and get your vendor or your open source project to pay attention to it. So you don't have to own it yourself either. So you can evangelize to your vendors and the projects that you work with about how easier it is if they deliver the code and their tools in a puppetized way. Okay, so finally I'm going to do some Q&A. And this is not you guys asking me questions to start out with, so I'm going to ask you guys a bunch of questions because we only get a few times to have these kind of direct one-to-one conversations with you. So we're interested to see what kind of people turn out at these events. And it helps inform the content and what we're doing. So first of all, everybody raise their hand. Everybody in the audience. Everybody. It's easier if everyone raises because they're not embarrassed. Everybody, come on. All right. All right. That's right. Keep your hands up. Keep your hands up. Have you used Puppet? If you've used Puppet, keep your hand up. All right. Have you used how many people are started using Puppet at 2.6 or later? Right, everyone's still up. Okay. 2.5 or later. 0.24 or later. 0.23, that's as far back as I'm going to go. I'm not going to, all right. That's good. So we can see this wave of adoption. It's nice to see. And this is where I ask you guys another question. Have you contributed to a Puppet Labs project? All your hands up. So everybody that's contributed to a Puppet Labs project. All right. That's disappointing. So all you people in the middle that have just used 2.6 and above, we accept pull requests, and we really want you to contribute. But we don't necessarily want you to contribute just to the canonical main Puppet project. There are all kinds of ways you can contribute. So I already spoke about contributing modules to the Puppet Forge. So how many people have contributed a module to the Puppet Forge? Ooh. All right. So we want to get that number up. And we will help with that, and Dan's going to talk about how we're going to help with that. So the people that contribute to the Forge are a small number of people. How many contributed to an existing module or just wrote their own damn module? Existing module? Okay, that's good. I know Dan has in the back. So it's interesting, we had an internal conversation about this where one of our new professional services guys was like, look, I just had to rewrite this entire module, so I just figured I'd publish it under my own namespace instead of a pull request. And we were like, no, that's actually not the point, because while it takes more effort for you to contribute to someone else's module, it means that they've learned something, you've learned something, and it's an incremental, it's a cost. Certainly it's a cost to doing that, but that conversation is important because you have the capacity to both grow from that, and then we're going to have consolidated work on things. That's far better. All right, I'm going to skip some of these because there's so few people. Well, how many people that have here have written a custom type, whether or not it's in their own environments? Custom function. Fact? It's kind of more hands. Yes, lots of people write facts. Do your facts do things, or do they just report on things? Because don't make facts do things. They should just report. All right, how many people have contributed? I know this is going to be low, to documentation. All right, we like that too. So if you don't feel like you can contribute with code, but you find that our documentation sucks, contribute to the documentation. We're happy to take pull requests on that. New for Puppet is Windows. So how many people have used Puppet on Windows yet? Small. The Windows support is quite good these days. One of the things that I really am proud about in my team is we used the Windows support to configure ESX and Virtual Center. So we literally at EMC World, in front of 6,000 people, scripted them out of a job. So we basically said, look, you can, with Puppet, automatically configure Virtual Center and attach ESX nodes to it. You guys have been doing this manually with your professional services teams for 5 years now. We automated it. And that's a hard thing to manage on Windows, so it's a testament to our Windows support being pretty good. How many people have used Razor? I should have probably said heard of. No? But, oh, have you used Razor? Testing. Okay. I encourage you to check it out. Most people already have their bare metal provisioning thing, but there's some advantage to it. One of the things that we tried to do when we built Razor is we puppetized it. We ate our own dog food. So you could easily go to the Puppet Forge, download the Razor module, and have a Razor environment set up except for DHCP, because we didn't think automatically turning up DHCP servers on people's networks would be the wise thing to do. So. All right, I didn't talk about this as being new because it's kind of old, but how many people here use mCollective or know what it is? Cool. For those that you don't know, mCollective is a message bus that we use to communicate to our nodes and ask them questions so you can do dynamic things with Puppet. Here, people use Hyra already. Cool. Who's tried out PuppetDB? Which sadly we didn't ship Puppet modules with. So how many people here have used stored configs before? How many people stopped using stored configs? Hands up if you've stopped. If you've stopped using stored configs but you like the functionality, just drop in PuppetDB. It's really fast, and you'll get that functionality rapidly. Okay. How many people have downloaded and used a Puppet module from the Forge without any modification? All right, that's our fault. We want you to be able to download this content more. It's also the community, so we need to be able to make reusable modules. I know Al will talk about that. All right, so this is kind of another question. Do you use the Puppet dashboard? Who uses Puppet dashboard? Who uses Foreman? About balanced? Who uses neither? That uses Puppet. So did you guys write your own? Who wrote their own node classifier? Dan. How many node classifiers have you written, Dan? Yeah. So that's interesting because we want to be able to have some consolidation there, and we're trying to think about what we want that to look like. All right. So how many people here have attended a Puppet Labs class? All right. We have training classes. I think they're quite good. I wrote the original ones, so of course I would think that. Dan and I both taught a lot of the classes. We've done a lot of work to improve them recently, and so we're going to have a new set of classes coming out. And for those people that care about certifications, we'll have a certification course that we're kind of modeling after certifications that matter, like Red Hat's certified engineer. So it's not going to be just a candy certification. Yes, Dan? I was going to say, are you going to ask that question? Who would like to be certified? Yeah, who would like to be certified? A small number. Okay. And this might be more of an open source crowd, but in our corporate crowd, it's certainly like things people care about. They want to go to our training, but they want some kind of, some kind of assessment of whether or not they absorb the material. All right. So those are all the questions I have for you. We have a few minutes for questions from me about anything that I've covered. So hopefully you guys have warmed up and thought of things with that round of questioning, so we can ask me questions. Yes. Okay, so the question is, what's the plan around version control in PuppetDB? And the answer to that is that's not the appropriate place for version control, because PuppetDB is a result of your of the things that you're version controlling. It only takes things that are the end result. Like you get not the Puppet code stored in it, but the model that the Puppet code generates.
And then the external node classifier, it doesn't act as external node classifier.
It does not act as an external node classifier. That's separate. That's you telling the world something. Like that's you deciding. So for people that are new, an external node classifier is a way for you to somewhere else in your infrastructure have a database of the machines you're managing and what their roles are, and maybe some parameters that you want to pass to those machines. And we have an API for writing your own. So oftentimes people have their own configuration management databases or whatever. PuppetDB is absolutely not designed to do that. We're working on a next generation node classifier that, because we find that everyone, like Dan's written 5 node classifiers, so we've found that everyone has some common needs, and we can make it a more rich API so people don't have to write their own. They can just get a ton of things out of the API. And also, it'll have Hyra integration into it as well. Other questions? Yes?
You mentioned consolidation between the Foreman and Puppet dashboard. Can you say a bit more about that?
Yeah, and so we're looking at what to do there, largely because the dashboard is a monolithic Rails app, and we're moving to a bunch of services for Puppet. And so it's kind of interesting to understand if there's parity between the two. Do we make Foreman work with those, or do we encourage the Foreman community to make it work with our services on the back end and let it become the open source dashboard, or what? We don't know the answer to that yet, but we're certainly exploring those as ideas because we're certainly duplicating effort. And we're going to have to do some reworking with the dashboard because we're moving to services. So that's good. By the way, the move to services and a service-oriented architecture is good for everybody. It's also kind of our commitment to being open source. So if we write tools that talk to that are commercial, we're not going to have any secret APIs that no one else can write tools to besides us. So we'll expose all these APIs, these richer APIs, and then the dashboards or the front ends that people develop, both us or other folks, should be much lighter weight instead of containing all the data themselves. Other questions? Come on, someone else has another question. One more question. All right. Well, thank you very much, and I appreciate you guys all being here, and I'm sure the next speakers will have a ton of information about how you actually use Puppet, so I hope the introduction helped.